In keeping with this thematic of the conference on the movement of animals in the Near East, I'll briefly address the issue of the movement of ivory objects and the animals themselves that were suspected to be the source of the ivory. The time period I'm addressing begins approximately 1550 BC to 586 BC, which is a very long time period, one that saw enormous political, socioeconomic, and paleoenvironmental changes. However, given the fact that we have a rather short time today for this discussion, I won't go into all of these factors, but they are clearly very, very relevant to the issue of ivory trade in the Near East in general, through to the Aegean regions, of course. So essentially, I'm going to focus on archaeozoology. I'm sorry, we're back on bones for those of you who are more literary and iconographically oriented. Perhaps it's a way to kind of complete the picture. And I will focus not just on bones, but also on a more ecological approach to the problematic. Now, when I began this research about a year and a half ago, I was surprised, given the quantity of publications that we have on ivory, that there are still many gaps in our knowledge concerning this topic. And the gaps relate to two main issues still, which are very basic. One is what is the animals that is the source of the ivory? And the second is the issue of the provenance of these animals and of the ivory. Now, I'm not going to give you a lesson in archaeozoology, but essentially, because this is also basic stuff many of you probably know, but it's also a very fundamental issue in our understanding of provenance, because depending on which animal we're dealing with, the geographic distribution in the region will obviously be affected. So aside from the walrus, I think we have a rather wide range spectrum of animals that could potentially provide ivory for us in sites in the Near East. And one of the basic ways in which we can assess which animal we have in our hand when looking at ivory is actually just to look at the size and shape of the worked piece, the worked object. And because there are obvious constraints, if you have a small tooth, there's a certain limit as to what kind of object you can create. And this may sound very prosaic and mundane, but actually we often forget to look at that sort of fundamental issue. You can, of course, make lots of small objects from large ivory pieces, from canines and from tusks, but you can make large objects only from some very limited options. So when we look at this example, which are ivory bowls, in this case from Tel Safi, an Iron Age 1B site in Israel, we have very, very similar ivory bones from sites in Israel as well, like Megiddo, from the famous Megiddo ivory cache. We can see that the size of the bowl, which is given at the top here, the bowl diameter, that's Safi and Megiddo, the circumference of these worked objects, it's not possible that they could ever have been made from hippo, for example, because the hippo's circumference of a canine, which is the largest tooth, only reaches a maximum of about 23 centimeters. So we immediately have a constraint that directs us in our identification of the material. The size of the elephants, which are given here down below, this is circumference of the base of the tusk, is obviously much larger and gives us a lot more leeway, pointing us already without any other work in the direction that this is elephant ivory. I'd just like to point out one interesting elephant circumference of 56.5 centimeters from Mycenae. It's an extremely large animal. Compared to all the modern elephants, we actually don't have a giant of that size in our modern databases. So it's very interesting to see that the size over time of elephants may have reduced because of predation. But obviously, one of the most common ways in which we identify the source of the ivory is to look at the microstructure of the ivory piece itself. And this is essentially that we're looking at the growth structure of the dentine. And it differs significantly from that of bone, which is shown here, which has lamella. And each animal has a very distinctive pattern. Whoops, we dropped. Can I go back? Distinctive pattern inside the lamella structure. So ostensibly looking at these pictures, you say, well, you know, it's walking in the park. There's no big deal. We can identify every piece to a species. However, there's an enormous problem involved. And this is something that is reflected in the literature, because in so many of publications, the actual animal is not identified. One of the problems is that you need a fairly large piece of ivory in order to actually see these patterns. The second is the way in which the piece was worked, the object, so that if it was cut at a particular angle, it may distort the patterning that we see, comparing hippo to, say, pig. The other object is that often you need to destroy the piece of ivory to make a cross section in order to do something like measuring angulation in the ivory of elephants, which enables you to distinguish different kinds of elephants. You can distinguish mammoth from African elephant and supposedly Asian elephant from African elephants. There's enormous literature on this. I'm not going into all the details. But of course, one of the problems is that we're dealing with worked objects, so that they've been burnished, they've been polished, they've been changed. Often they're burnt, found in destruction layers, so that some of this patterning that looks very obvious is actually not so obvious. And obviously we have another problem that curators of museum collections and archaeologists don't like us archaeozoologists to break things and to tear bits off to have a look at the cross section. So often we actually are faced with a problematic that we cannot identify what we have in hand in terms of the source, the species source of the ivory. In recent years, we now have a whole range of new methods, I would say cutting edge methods for looking at ivory to identify species, which helps us then to identify provenance, one of which is Raman spectroscopy, which is fantastic because it's non-destructive. However, the size of the piece that you can use for analysis is limited, but it needs good collagen preservation. And this is a problematic I'll come to in a minute. The second is obviously DNA, which immediately would give you species, not just genus. Again, you need good collagen preservation. And the problem here is that it is destructive. You need to take a piece of ivory and grind it up and look at it. And the third new method, which is very, I think, interesting and useful, is zooms, where we look at the protein collagen structure, which is unique to each species. It doesn't give us distinction at the moment between elephant species, just tells you you have an elephant as opposed to a hippo. That in itself is useful, but it is also destructive. So the problem with all these methods is each one requires a different kind of sampling. It's a different level of work, a different budget as well. And I would suggest today, as we are doing in this project that I'm running in Israel, that we are trying to combine all of these approaches depending on the material. And one of the big problems, of course, is the preservation of collagen, which we need for all three of these new methods. And obviously we have a problem in the Near East. And we've run about 15 late bronze Iron Age pieces of ivory so far in Israel using zooms, for which you need less collagen than if you're running DNA. And sadly, we have no results. The material has undergone enormous diagenetic change so that we cannot actually apply this method. It may be site specific, but it's a fairly expensive, if you like, experiment, and you can't run hundreds of pieces and then find you're going to have 5 results only. But we're hoping it will work. It has worked in some sites. As a very good example that I bring here of the 7th to 10th century AD ivory assemblages from sites in South Africa. Obviously, the burial conditions of that material, the preservation conditions are different, but it worked, and they were able, therefore, to identify that there was elephant ivory at the site in all the pieces they checked, despite the fact that they did have the presence of skeletal remains of hippopotamus and warthog, wild pig. So this is a site where they couldn't assume that all the ivory was elephant because you had 2 other potential species that had been exploited in the site. So I think that we are heading now into a new era where we are able to utilize this wide range of different technologies to help us identify, or at a higher resolution, identify these species that we are dealing with. Now, clearly the species identification helps us with provenance because these animals live in different habitats and different places in time and space. So the question that really is of interest to us as archaeologists is, where does the ivory come from? Now, it can be traded locally. It can be obtained locally, sorry, or traded. Locally means there would be a local population of elephants or hippos or warthogs or whatever animal you're interested in, and that they were the source of the ivory that people then used to make objects. The alternative is that it was ivory that was brought in from distant area. And here we have two options. It could come in as a raw material that is then used and worked locally by local craftsmen, or it can come in as a ready-made object. And our big problem is actually to disentangle these 3 or 4 different options in order to specify what really is the provenance of the material that we have at hand. Now, I want to give a very good example of this problematic from the site of Tel Megiddo that I mentioned before. It's a massive ivory and gold hoard that was found actually in the 1930s. It's a very famous collection, probably one of our largest assemblages from the southern Levant. It was found in a very small area within a palace. Underneath this skeleton, which was incorrectly identified by the excavators as a camel, it's an equid, probably a donkey. Sadly, the skeleton has disappeared. The material then is buried underneath in a small room in the palace. There's some examples of the beautiful things that they found in relatively good condition when you look at them, although they have been preserved and curated intensively. We've tried, one of the samples that we tried for zooms was from Megiddo, from this hoard. And in fact, there's no collagen preserved. So what looks to be well-preserved material can actually be disconcertingly not well preserved for our purposes. But the more interesting factor from Megiddo is that many people have used provenance to understand provenance using stylistic analysis of the manner in which the objects were made. The objects that are carved, the images, the iconography. And there's a vast literature on ivory for the region, for the Near East in general and the Aegean, that uses only stylistic analyses in order to attribute origins to the ivory piece. But what we have in Megiddo is very interesting because we have a melange, a mixture of different styles. We have Egyptian motifs, as you can see here on the left. We have Hittite, Anatolian, Mycenaean images, and we also have Canaanite iconography. Many people have written about this. So you could say, right, this is a very luxurious palace where they were buying or obtaining material from different sources. However, there could have been local craftsmen who had been brought in who happened to make designs in an Egyptian way. Or there could have been Anatolian craftsmen who were actually working in the palace. So the question here is that style, I'm not denying that it has enormous value for us as archaeologists and archaeozoologists, but it is often very problematic. So we cannot actually rely solely on stylistic analysis in order to attribute provenance. Now, when we start looking more at the archaeozoology and the biogeography, which is what this section of the talk is about, we can provide a slightly more nuanced picture. When we look, however, at modern day biogeography of animals, we can see that it's absolutely useless because they're all living in very relic reduced circumstance. Today, we have hippos living only in the southern part of the Nile, and they are found in parts of sub-Saharan Africa. They are extinct today in Egypt from the 19th century. They're extinct in Southeast Asia, in India, for instance, circa 9000 BP. But they did exist there during periods not necessarily of interest to us, but during periods where people were living and utilizing ivory. And of course, in the Levant, they became extinct during the end of the Iron Age, circa 1000 BC to 586. So these maps are actually quite useless to us. We need to take into account a broader biogeographic perspective based on archaeozoology. When we look at elephants, we have exactly the same problem. We have the extinction of elephants in the Levant, about 250,000 BP. And then we have absence of elephant, but we have ivory objects, including tusks. We have a continuous presence in sub-Saharan Africa, but they are not present in Egypt from about 4,000 BP. So it's an issue we'll come back to. And of course, there's a continuous presence in Southeast Asia, but they're in a much more limited range than they existed in the past. These dark areas show where there still are relic elephant populations, mainly in nature reserves. So of course, we have to now extrapolate looking at the archaeozoological literature to give us a more complete biogeographic picture. So the working assumption as an archaeozoologist for me would be that the moment we find bones of an animal, postcranial remains, as opposed to tusks or teeth or worked ivory bits, the moment we find them in an archaeological site, it is potentially a reflection that the animal was present locally. This is true particularly in the case of massive animals like hippopotamus and elephant. These are animals that weigh, I mean, the savanna African elephant, 6,000 kilos, you know, a couple of tons. The bush elephant, 2,700 kilo. Asian elephant, who's pretty small, only 4,000 kilos. And a hippo, 1,800 kilo. These are animals whose bones you would not take home unless you have to. And what you would do if you are exploiting them for food or other products is strip them where you kill them, butcher them, and bring back only useful parts. Now, we call this the Schlepp effect. We talk about this a lot in prehistoric sites, where people selectively bring back elements of an animal to a site. But with these very large animals, even in prehistoric times, it is very rare that people would have transported large parts of postcranial remains back to the site. In addition, the hippo and elephant, the bone itself, because of its particular composition, is not an especially good raw material for artifact manufacture. So that, in fact, we don't have any evidence from late Bronze Age, Iron Age sites of elephant bone being used to make artifacts, as opposed to ivory from the teeth. So we have a few exceptions. There are Chilean bifaces. It's a kind of another story, another world. So essentially what I would argue, and one could discuss this assumption that it's maybe faulty, is at the moment we have bones, postcranial remains that are not used necessarily for ivory exploitation of elephant and hippo. This would say to us, these animals were exploited locally as opposed to imported. Now, what we do, what I've done in order to complete the record of the biogeographic distribution of animals is to then plot where their bones are found in archaeological sites. This is a work in progress, and it's been curtailed a little because I didn't have access to the libraries the last few months. We're under lockdown again in Israel. We finish hopefully on Sunday. So this is a kind of work in progress. From a paper I published many years ago, 1990, you can see the red dots here are late Bronze Iron Age sites with hippopotamus bones. And you can see they go up in the northern Levant. There are a few in the southern Levant. All the black dots are Pleistocene. So these are middle Paleolithic, Acheulean sites, early sites. A few sites here marked off in the Delta region of Egypt with, there are many, many more. And these are early pre-dynastic or early dynastic sites. There are others. And then when we do a zoom in onto the map on the right-hand side, my right-hand side, of late Bronze Age, Iron Age sites just in southern Levant. I haven't finished data for northern Levant. The red dots again are Iron Age and late Bronze Age sites. But we can also see there are bones from earlier periods, Chalcolithic, Middle Bronze, Early Bronze Age. To my mind, and as I have published, I would say that this is a very good direct evidence for the biogeographic presence of hippopotamus along the coastal area of the Levant. And this would now bring us into the periods that are of interest to us for the exploitation of ivory, because we now have a potential local population in the Levant of animals that could have been exploited for the ivory in order to make objects. Obviously, Egypt would also have been a source at the time. We now look at elephant remains using exactly the same approach, looking at bones. All the sites with red dots are sites where elephant bones have been found, not tusks. I'm not talking about tusks and certainly not worked objects at the moment. There's a few things that are very interesting. The first is that none are found below this line, which is pretty much the Litani River in southern part of Lebanon. So in the southern Levant, area of, say, southern Lebanon, Egypt, Jordan, Israel, sorry, and Jordan, we have no skeletal remains of elephants to date from any archaeological site. They are, however, found in many sites. And this is, I think, the strength of this argumentation that I'm trying to put forward. They're found in many sites. It's not just one or two bones also. And they're found along the Orontes River. They're found along the Euphrates. And there are a few sites also along the Tigris. This would seem to support, as opposed to what many of our colleagues have argued, that actually there was a local elephant population living during the late Bronze and Iron Age in this region. But it's a broader region, not just the Orontes area, it's the entire basin of the Orontes, Euphrates, Tigris. And this system runs all the way down towards the Persian Gulf. And so that would be a conduit, a very logical entry point for elephants to enter into this region. When we look now at another map of distribution, there are a few things to see. This is a map that gives both objects, tusks, and ivory and postcranial remains of hippos, which are in red, and the elephants that are in green. But this gives us a picture of what happened in an earlier period beginning around 3,500 BC, the early Bronze Age for the region. And a few points to look at. The first thing is that we have some elephant postcranial remains, bones, here already in sites along the Euphrates. So we have Tel Kitar, Munbaka, and Asmar. These sites all have not just tusks, they also have elephant bones. However, hippopotamus remains are very rare or less common, let's say, in sites in the northern Levant. They are far more in the southern Levant that is almost entirely made up of hippopotamus bone, hippopotamus tusk, and hippopotamus objects. So this is kind of interesting issue. Obviously here, this little inset map, we can see the whole Nile Delta is full of hippo bones, and they are obviously hippopotamus objects. So there's a clear divide here in the early Bronze Age, Middle Bronze Age, between the northern and southern Levant in terms of what objects are made of. There's a clear emphasis on hippopotamus in the southern Levant and an emphasis on ivory objects from elephants in the northern Levant. In addition, as we saw in the previous slide, we have elephant bones in the northern Levant, but their absence in the southern Levant in the late Bronze period, Iron Age period. However, what happens in the southern Levant in the late Bronze Age, Iron Age, in terms of objects made of ivory? Let's just go on. I just wanted to find this map, sorry. We'll come back to the others. And this is kind of interesting because we can see, that's the map I'm looking for, sorry. We can see there's a shift, a changeover. This is sites from the late Bronze Iron Age in the southern Levant. The red dots are hippo, the green dots are ivory from elephants. And we can see that we now have a change. We have objects made from both hippopotamus and elephant in the southern Levant in this later period. So there's a major shift from the early Bronze, Middle Bronze Age, where we only had hippo ivory in most of these sites. There are a few objects of elephant ivory, but they are really a minority. So it's kind of interesting. I'll go back now a few slides, if I may. I sort of got ahead of myself. So if we can kind of summarize what we have at the moment, we could say that from the Middle Bronze Age, because we do have elephant remains in some sites, the Orontes Valley Euphrates River system actually sustained probably a local population of elephants. And we have many other written sources about elephant hunting in the region in the late Bronze Age. There are iconographic records of elephants, and I haven't brought all of this here. It's all been published by other people as well. So I think it's fairly well established. We obviously have masses of ivory artifacts and unworked ivory tusks as well. So we have the full repertoire of materials relating particularly to elephants in the northern Levant. So the question still remains then, some people have questioned whether they're live animals. Some people have suggested they were sent as tribute from Asia to the region, or as aid in military campaigns. However, we have absolutely no evidence that elephants at this point in time were tamed or domesticated. So it would have meant this would be the earliest evidence for taming or domesticating of an elephant. There's no other way you can transport it from Southeast Asia all the way across to Syria, to the Orontes area. So I think those are very weak arguments. I think the archaeozoology is very tight and gives us a very good, compelling argument for local population of animals. And in fact, Peter Palsner published a few papers, most notably in 2016 in Syria, where he argues that the region of the Orontes Euphrates would provide a perfect habitat in terms of ecology for elephants. It's marshy. It was an area that wasn't highly settled or intensively settled at that point in time. And in fact, it's an area that resembles very much the Amboseli Park in the reserve today in Kenya, where the elephants come during the day from the very dry area around to the marsh area, where they spend the entire day, and then they leave again at night because it's not safe for them to stay in the marsh. They're much more exposed to predators. So I think we have many of the ecological pieces also in place here to argue for the existence of local population of elephants. We have an additional new data set relating to DNA. Elephant remains found in a natural setting. They are not connected to archaeological sites. From the Gavur swamp area, there are several individuals or bits of individuals. They dated exactly to the time period we're interested in, 3,500 BP, so it would make them late Bronze Age. They carry a rare haplotype which has only been found in a modern elephant from Thailand. And based on the morphometric study of these remains, the crania, the teeth, these are definitely Asian elephants. So these animals would have to have come somewhere from India, from Southeast Asia, Burma, Thailand, whatever, and made their way across to the region of the Euphrates and the Orontes. And so I think we now have a fairly good data set from the genetic data, the ecology, the archaeozoology to really argue we had a local population of elephants that existed there. They are not connected to the Pleistocene elephants that existed and disappeared in the region circa 250,000 years ago. They are a new pulse, a new invasion of animals. And this is the movement, connects to the thematic of the animals. It's a new movement of animals that enter this river system, I think connected to the climatic change. My colleagues who published this DNA paper, Gerland and Flink, they argued that it would have been during a wet pulse that they entered the system. It's a period mid-Holocene of great paleoclimatic change. I think actually it was a period that was dry. And we know that the late Bronze Age, we have a collapse in the paleoclimatic system in the Near East. And so if it's a dry period, elephants would be looking for water, looking for new resources, and this would engender a movement perhaps westward, into this area which is more connected to the Euphrates Tigris. So that would be my main argument. We also have an interesting ecological parallel from today, from South Africa, which is where I come from, of elephants that are found in a small area on the east coast of South Africa called the Knysna Forest. These are animals that are documented as having entered a very small area. Today it covers only 3,100 kilometers square. They entered this in historical period of 1700s, 1800s, when they were being poached en masse and their land was being taken by farmers. So they were really being pressured. The elephants retreated into this small area. There were approximately 400 to 500 individuals beginning in 1876. That's the first count that we have, historic count. They now reduced to between 8 to 1 individual. They're really not sure. The DNA says 8 individuals, DNA based on dung. And now, during the last lockdown in South Africa, they managed to actually photograph one of these elusive animals. Here it is, 45-year-old female. It's the first sighting in many, many years. So that these animals within a rather small area, within a very urbanized area of South Africa, are able to disappear and no one can see them. They don't know, they can't find them. Now, this is a very small area because if we look at the home range today for wild African elephants, and this is an African elephant, the males can travel over 11,000 kilometers square as a territory. Females have a smaller space. Asian elephants, 400 kilometers square, almost double that for males. So we have here a very small area, and entire herds of elephants disappeared into these forests. People didn't know about them, they couldn't find them, and they've managed to survive. So I would argue that this again gives us a precedent, not necessarily one-to-one comparison, for the feasibility that animals as large as elephants could have lived quietly side by side with people in the late Bronze Age, Iron Age along this Euphrates-Orontes system. We've been through that. Now, one of the big factors connected to this pattern that I showed before of the late Bronze Age, Iron Age, the shift in ivory exploitation in the southern Levant, where suddenly elephant ivory is visible in large quantities, such as at Tel Megiddo that you saw, is the fact that in Egypt, the elephant in Egypt itself is extinct already by the time we have reached the late Bronze Age in the southern Levant. The disappearance of elephants, based again on their postcranial remains, not on ivories, occurs around this time period during the Old Kingdom. So that by the time we arrive at the New Kingdom, which is our late Bronze Age period equivalent in the Levant, we don't actually have elephants in Egypt. It means that Egypt, in order to obtain elephant ivory, would have had to send missions further south into southern Sudan, where today we still have forest elephants remaining. This would have been an enormous costly activity. It also increases the distance of transportation of ivory from Egypt all the way up. If we can look at the map here, all the way up, it's a fair distance. You have to bypass also, if not by ship, you have to bypass the Sinai Peninsula. There was, of course, a trade route, the way of Horus that existed into the New Kingdom. But at this time as well, the hegemony of Egypt in the southern Levant is now undergoing enormous change and is being challenged by the collapse of late Bronze Age societies in the Aegean and the rise of communities in Mesopotamia and Assyria. So there are also political constraints which might have, I would say, curtailed Egyptian trade in ivory into this region. In contrast, we have now an Orontes-Euphrates source of Asian elephant ivory that could have replaced Egypt as a primary source. This, of course, is something that would need now to be documented by actually identifying what kind of animal we have, what is the source, the species source of the ivories that we have in the Levant. But I would argue that it was a major shift in focus so that, in fact, the northern Levant becomes the source of elephant ivory. In terms of the hippo, we have local populations of hippos still existing in the Levant, so they could have been exploited throughout the period, and Egypt was not necessarily the main source of hippo ivory at this time. In terms, as I said before, for the elephants, the Euphrates area, Orontes, is much closer to the southern Levant. It's a less arduous trip, maybe reduced even the cost of ivories. They maybe became cheaper. And we know, of course, that there were maritime trade links, so that would be another option. I don't know about costs. Traveling along the Mediterranean coast was also hazardous and could only be undertaken seasonally. So this in itself would have curtailed the movement. However, I think the exploitation, this large-scale exploitation of elephant and hippo ivory during the late Bronze Age led finally to the extinction of these animals in the region, so that this newly entered species or this community of Syrian elephants are short-lived and they disappear by the end of the Iron Age, as do the hippopotami from the entire region, we do not find their remains, as in bone remains, in archaeological sites in later periods. So I think this is a fairly new approach in some way to look at this data, at this problematic. The data still needs to be put in place, but it's beginning to coalesce. If I may finish on a kind of slightly humorous note, just this whole problematic about elephants, their presence, disappearance, reminded me of a very beautiful novella by Terry Pratchett, the humorist, called The Fifth Elephant. And he begins the short story by saying that 4 elephants actually support the world, and they themselves are standing on top of a turtle. And suddenly, a 5th element comes falling down through the atmosphere and crashes onto the earth, and it lands hard enough to split the earth, to raise continents and mountains. It's a tremendous impact. However, no one actually saw it land, the elephant, which raises the interesting philosophical question, he writes, when millions and tons of angry elephant come spinning through the air and there is no one to hear it, does it, philosophically speaking, make a noise? And if there was no one to see it actually hit the earth, did it actually hit? And I think this is part of the problem that we have in our issue here dealing with elephants and ivory, is that we are grappling at the small pieces, the evidence, to say, yes, we did see them hit the earth. We do know that they existed. So I thank you all for your patience and for staying on to listen to this last talk.